Good evening. So you and I are living through the coronavirus pandemic. You know the impact it's had on you, on your family, on our society. But you're also living through the pandemic of HIV, a disease which has claimed the lives of millions of people. It's led to so many people growing up without parents and family members. Well, tomorrow, it's 40 years since the first fatal case of HIV/AIDS was reported. Professor Salim Abdool Karim is the director of CAPRISA. He spent almost all of his life dealing with this pandemic and then, of course, with COVID-19. Professor, good afternoon to you, and thanks very much indeed for your time. So how did scientists first realize there was something that we now know to be HIV?
Yes, a very good evening, Stephen. Good evening to all of the viewers. When you think back on June 5th, 1981, an article that didn't attract that much attention in its first few days was published in the MMWR, that's the publication of the US CDC. And in that article, they described 5 patients from Los Angeles that had developed a very unusual pneumonia. That pneumonia is due to an organism called Pneumocystis carinii. Shortly thereafter, several new reports came up. Reports from San Francisco, reports from New York of patients with Kaposi sarcoma, and all kinds of unusual conditions. And so, exactly 40 years ago tomorrow, the world came to know about the existence of a disease called AIDS. Initially, it was called the gay disease. Initially, it was given all kinds of terminology because people were scared. But with time, we've now come to understand that in its initial manifestations of severe immunodeficiencies, we were seeing this range of conditions. It took about another 20, 25 years before retrospective testing actually identified the first ever patient that we know of who had AIDS, and it was a patient in Kinshasa that had a blood stored from 1959. So we know that the earliest possible patient probably came from the DRC or in that area, but the case that brought the attention of the world to AIDS occurred in Los Angeles 40 years ago.
I suppose one of the problems was that if you don't know that a disease like HIV exists, which compromises your immune system, when you're presented with a very rare pneumonia in this case, or I forget the pronunciation, but a sarcoma, you actually have to do quite a lot of work to work out why this patient has that particular disease first.
You're absolutely right. When you think about it, you don't know whether this is nutritional, you don't know whether this is environmental, you don't know if it's infectious. So what we saw in those very early days was everyone was scared. It reminded me of, and I think back to March of last year, and we were all waiting for this disease. This first patient from Italy had come back from Italy, had been described. And we didn't know a lot about this. And so we were hesitant, and you could see in our way in which we were dealing with COVID, many of the same features of how we initially dealt with AIDS when we didn't know this. Could we touch them? Could they come to school? Could they, be with us? And today, of course, it's all now something that we know quite well and we deal with in our everyday lives. But that process of building our scientific knowledge so that we understand and know what we're dealing with is a critically important pathway that we follow in science that enables us to deal with epidemics like this.
We've known, and I think you and I have discussed this before, how quickly our knowledge of COVID-19 has grown from, December 2020, December 2019, in fact, I think was the first case reported to the World Health Organization to now. The amount that we've known is just incredible. With HIV, I presume it was a much smaller process. Firstly, just a couple of researchers working on this, not really knowing what they were dealing with. So it would have taken a lot longer to know what was actually going on.
Yeah, and I think there's a very big difference that we don't always fully appreciate, that when you get HIV infection, it takes on average about 7 years before you get clinically ill. Whereas with COVID, it takes less than 5 days. So you have a very big difference in scale. So when we were seeing the first patients with AIDS that were quite severely ill and described in that initial paper 40 years ago, they actually became infected some 7 years or so prior on average. So the rate at which our knowledge grew with HIV was much slower. For example, we knew the first case in 81, but it was only in 83 that we had the discovery of the virus. So we spent almost 2.5 years not knowing that this was being caused by a virus. We thought it was an infectious cause, and we did not know that it was a retrovirus like HIV. And then once we had the virus, it took almost a year before we had routinely available diagnostic tests. So the diagnostic tests only became available in 1984. So you just think about that time frame. In COVID, we knew the first cases were in December. 11th of January, we had the sequence and we knew the virus. And it was within a matter of 3 weeks that we had the first diagnostic test. So it's almost like HIV in fast forward.
It's really quite something when you consider the time difference. So one of the things about COVID-19 is it comes from a family of viruses that humans have a lot of, the coronaviruses. And again, we've all learned, including journalists, so much about it. So we know what coronaviruses are. It's probably a coronavirus that maybe just made you sneeze a moment ago, a harmless one, I hope. Then with HIV, did it come from a family, or does it come from a family of viruses that we knew something about, or was it something completely new?
So we did not really have a detailed understanding of retroviruses. At that stage, in 1981, a very eminent scientist called Bob Gallo, he was the director of the National Cancer Institute at the NIH at that time. He had made the discovery of the first retrovirus that we know about, called HTLV1. Today we know it causes spastic periparesis and so on. He also discovered HTLV2. And so when this retrovirus was first described, and his laboratory was among those working on it at the time, he called it HTLV3 as a follow-on to the previous two retroviruses that he had discovered. But it turned out that HIV was a different class of retroviruses compared to HTLV1 and 2. But what we had learned from HTLV1 and 2 was we had learned about a lot of the basic, the essence of how retroviruses grow. So the difference between HIV and the coronavirus is really around two things. Both are RNA viruses. So let's start there. Both are RNA viruses. HIV has a step in it where the virus carries an enzyme that enables the virus to integrate itself into our human cells. So that's why once you have HIV, you can't get rid of it. You've got it for life because it's inside your own cells. Coronaviruses can't do that. But coronaviruses do a range of other things. And one of the big differences is that it has a very long sequence of its gene. And so it has the ability to make many more changes that are still functional. HIV makes changes on a much more rapid basis, but not all of them are functionally and antigenically different.
So obviously now, I mean, in those days, HIV, and I mean, I remember for a time, my memory of it won't be nearly as good as yours, but you know, people saw HIV/AIDS as a death sentence. And then, I think looking back now, and I mean, for so many people it was, of course. I mean, we lost millions of South Africans as a result. But then ARVs came along, and they were very expensive, very difficult at first. And then looking back, it seems almost quite quickly, they suddenly became affordable to the point where millions of people get them on a, take them on a daily basis in our country.
Gracia and I were studying at Columbia University in 1988, and we had the opportunity of listening to Samuel Broder. He gave this incredible talk. I mean, it really stimulated both of us to go and do work on HIV, where he described the first ever trial of AZT to treat patients with AIDS. And as he described it, we were just amazed at its impact. When you think back to that trial in 1988, it took 8 years, in 1996, for Sperling and colleagues to discover that if you use AZT, you can prevent babies from getting infected from their mothers. And it took 2 years further, in 1998, at the conference in Vancouver, for the world to hear about something new. It was called HAART, Highly Active Antiretroviral Therapy. 3 antiretroviral drugs combined with each other. And David Ho stood up in that podium, and I remember marveling at how he presented the amazing results of HAART. And then comes the conference in 2000, and we are now understanding that the world is split. We are living in 2 worlds. Those who can afford shall live and survive, and those who are in poor countries shall not get access to these treatments. That was not something we could tolerate. And so we saw Zaki Ahmed, Mark Haywood, and a whole range of activists at the AIDS conference put that on the agenda. And that conference was a turning point, because at that conference everybody pledged, and President Nelson Mandela did the closing, in which he got 17 standing ovations, and he got all of us on the same page that this was unacceptable. We needed to remedy that. And within a matter of 2 years, we had the creation of the Global Fund. We had the system of voluntary licensing starting, where companies in India were being given licenses to make generics that were affordable, and the cost of the drugs came to below $1 per day. And we just saw this transformation in a matter of 2 to 3 years. In COVID, we have seen this in a different way, in that we haven't been able to see the voluntary licensing with vaccines in the way that we would like. But we're seeing now changes occurring in terms of intellectual property waivers and so on. So this whole change in medicine and access has been a path that's been set by HIV that all other diseases are building on.
Professor, I mean, there's an awful lot around that AIDS conference in 2000 that also happened that I know was also very difficult. I do want to ask, though, we've seen so much scientific brain power, including yours, put on the COVID-19 virus. And I know that the search for an HIV vaccine helped to speed up the search for a coronavirus vaccine, for a COVID-19 vaccine, which we now have. Could what we've learnt during the search for a COVID-19 vaccine now return the favor and help us in the future with the search for an HIV vaccine?
Absolutely. So the reason that South Africa played such a big role in vaccine development, remember, we contributed over 4,000 patients just to the J&J trial, and we were involved as a country contributing to 4 of the 8 COVID vaccines currently licensed. So that's quite a big contribution to make for a small country. And how is it we could do that? We could do that because of the huge infrastructure that has been built and the technically capable people who have been trained in order to do these vaccine trials. And that's what gave us a head start. That's why we've played such a big role in vaccine testing in our country. Now that we've done that, we've got a lot of experience in how these studies can be done quickly. But for me, the critical way in which COVID is going to transform our search for and our work on developing an HIV vaccine is the use of mRNA technology. mRNA technology has held promise for more than a decade, but we just didn't see it delivering on that promise. There were all kinds of studies being done, developments on mRNA, but COVID became the pathway that released the power of mRNA vaccines. And mRNA vaccines, I have no doubt, the mRNA, the messenger RNA, we call it for short mRNA technology, is now going to be one of the foundation stones of our research on HIV vaccines.
Professor Salim Abdool Karim, Director at CAPRISA, always good to talk to you, sir. Thank you very much indeed. Really fascinating history of HIV, how important it's been in our society. Coming up, Tumi Khaswe with your sport. Stay with us.